Hello my dear children. All of you please stand up for a silent prayer. Okay, sit down. How are you all? I hope all of you are doing well and safe. This is our first mathematics class, right? So I think let's start this class by doing a small activity. Are you ready? All of you take a scale. Go and take your scale and come back.
So, all of you took your scale, isn't it? Now, look at the portion between 0 centimeter and 1 centimeter. Tell me, how many divisions are there in between 0 and 1? Yes, there are 10 equal divisions in between 0 and 1. Very good. And what measurement each of these small division indicates? Yes, it's millimeter, isn't it? First small division is 1 millimeter and the second small division is 2 millimeter and so on. So, you can see an arrow corresponding to a particular division. My question is, what is that division indicates? Yes, it's 6 millimeter. Very good. Now, can you represent 6 millimeter in centimeter? Okay, before doing that, let's recall something. You all said that the portion between 0 centimeter and 1 centimeter is divided into 10 equal parts, isn't it? Now, 1 centimeter must be equivalent to 10 millimeter. Very good. In thinking reverse, what will be 1 millimeter? Yes, it will be 1 by 10th of the centimeter. Okay. Now coming back to our question. How will you represent 6 millimeter in centimeter? Think. You all know 1 millimeter is 1 by 10 centimeter. So what will be 6 millimeter? Yes, it will be 6 by 10 centimeter. You all know how to represent 6 by 10 millimeter or 6 millimeter in decimal form, isn't it? What was that? Yes, it's 0.6. We sometimes say 1 millimeter or 0.1 centimeter. Now, can you tell me how to represent 2 millimeter in centimeter? Yes, same as the before. The first step is 2 by 10 centimeter and it indicates 0.2 centimeter. So now we have seen that 6 by 10 can be represented as 0.6 and vice versa. Similarly, 2 by 10 can be represented as 0.2 and vice versa. So, see, if you have a fraction with the denominator 10, you can represent it in a decimal form. And similarly, if you have a decimal form, you can represent it in a fraction form, isn't it? So, keep this result in your mind. Do you remember the question in the slide that you have done in standard 6? Okay, let's do it once again. Sajin measured the length of a table as 1 meter and 13 centimeters. How do we say it in meters only? Read once again. Sajin measured the length of a table as 1 meter and 13 centimeters. How do we say it in meters only? Before doing this problem, let's recall some other thing. Tell me, what is 1 meter? Tell me 1 meter in centimeters. Yes, it's 100 centimeter. Very good. Then tell me, what will be 1 centimeter? This will be equivalent to 1 by 100 meter. Very good. Now, coming back to our problem, we have 1 meter and 13 centimeters. You have to convert the whole measurement into meters. So, tell me, what is 13 centimeters? Or how we represent 13 centimeters in meter by using the result above? Yes, this will be 13 by 100 meters. Very good. Now tell me what will be 1 meter and 13 centimeters in meter. Correct. This will be 113 by 100 meter. And you already learned that this same fraction can be represented in decimal as 1.13 meter. Isn't it? In the same chapter, in the same question, we have learned the same. So by comparing these two fractions, what can we say? 13 by 100 is equivalent to 0.13 and which can be written as 0.13. 0.13 and 0.13 are same. So always remember that it's always better to write a decimal form in as 0.13. Put a 0 before the dot or the decimal point. So I hope you understood the question. Let's do one more problem. Tell me how you convert 4 meter and 28 centimeter into meters. What is the first step? Correct. 28 centimeter is written as 28 by 100 meter. Then 4 meter and 28 centimeter is written as 4 28 by 100 meter. Very good. And the decimal form of this is 4.28 meters. So by comparing these two fractions, what you can say? Yes, 28 by 100 is equivalent to 0.28 or 0.28. So I repeat, it's always better to write 0.28. Very good. Now let's analyze what we have seen till now. In the first activity, we seen that 2 by 10 can be represented as 0.2 and 6 by 10 can be represented as 0.6. Similarly, 9 by 10 can be represented as, yes, 0.9. Very good. See, can you see any similarity in the fraction? Yes, all these fractions have denominator 10 and correspondingly the decimal form is represented in a similar manner. Now coming back to the second set of fractions, that is 13 by 100 is equivalent to 0.13 and 28 by 100 is equivalent to 0.28 and 98 by 100 is equivalent to 0.98. In all these questions, the left hand side or the fraction we considered have denominator 100. Similarly, we write the decimal form in a particular manner, isn't it? Now, by analyzing these two, let's try to do another set of fractions with the denominator 1000. Okay. By analyzing 2 by 10 and 13 by 100, can you represent 875 divided by 1000 in decimal form? Yes, it's 0.875. Very good. What will be the decimal form of 347 by 1000? Yes, it's 0.347. What about 673 by 1000? Yes, it is 0.673. Very good. Now let's summarize what we have seen till now. A fraction whose denominator is a power of 10 can be represented in decimal form. What is power of 10? Yes, it's 10, 100, 1000, 10,000 and so on. So any fraction whose denominator is 10, 100, 1000, 10,000 or more can be represented in a decimal form and vice versa. Now let's try out some problems. First question, what is 7 by 10? Yes, it's 0.7. What is 33 by 100? Yes, it's 0.33. Then what is 999 divided by 1000? Yes, 0.999. Similarly, I have given the decimal form. You have to convert it into fraction form. What is the fraction form of 0.5? Yes, it's 5 by 10. What will be 0.29's fraction form? 29 by 100. And the last one is 855 divided by 1000. So here are some homework questions for you. You have to write it down and find the answer by yourself, and we will discuss the answers in the next class.